In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played...
I was like, fuck.
All right. Hello and
That's
welcome,
like
everyone.
Just another sea lion.
Yeah.
Nice. So for research and reading night tonight, I came across this YouTube channel a couple of weeks ago, and I really like his work and what he's putting out, and I wanted to share some of it. So we've been getting into the math stuff a lot lately, and, you know, talking about rotations and whatnot, and that involves a lot of cross products and dot products and whatnot. So I figured we'd learn a little bit about that tonight through this guy. It's pretty entertaining, I think. And then he's got another video about what's actually waving, so that the old etheric medium, perhaps. And then we're going to watch his video on why the magnetic force is perpendicular to the magnetic field. So, and then I think Stone had some commentary to add to this video or this video. So, and if anyone has any questions, comments, or whatever during the video, pause or you know, feel free to ask. I don't know if I'll be able to answer it, but I'm sure Stone may know a thing or two about the old dot products and stuff. So,
Or not.
or not. Okay, I was just gonna throw in a Hail Mary out there.
Oh, that's cool. Yeah.
But anyway, here's his channel, and we'll start with the math stuff first, and then we'll get into the other stuff.
Dot product and cross products is a... Were you taught the dot product and cross products as a string of random definitions and mathematical procedures that have nothing to do with reality? Or perhaps you were given certain applications, such as work or torque, but you were wondering how these really specific mathematical methods actually relate to those applications. Let's demystify all of this here on Inductica. The dot product was created as a mathematical operation for understanding the physical process of work and other similar concepts. What we're going to do in this video is understand the dot product and cross product by understanding the observations in physics that they were derived from. When a force pushes on an object, it will do work equal to that force multiplied by the distance over which that force was exerted. Now, if you haven't taken a physics class and you're not sure what work is, just think of it as the total energy or the total motion delivered to an object when a force pushes on it. It's not always this simple, though. Think of a train that's able to move back and forth on a track. Now, imagine that some incredible wind blows at an angle to the train, pushing it forward. To figure out the work that the wind does in this kind of case, we have to break the wind vector into two separate components. One which is parallel to the track, a component that actually contributes to the train's motion, and a second component which is perpendicular to the track, a component which does not contribute to the train's motion. To get the actual change in motion in a case like this, we don't multiply the distance by the force. Instead, we multiply the distance by the component of force that actually contributes to the train's motion. From this diagram, you can see that this is F times cosine of theta. So the work is F times D times cosine of theta. The result is a scalar, not a vector, because work refers to the amount of motion that a force causes without thinking about the direction of that motion. Now, this equation is one way to calculate the dot product, and it works when you actually know the angle between the two vectors. So specifically, the dot product calculates work, but more generally, the way you want to think of the dot product generally is that we use it when we want to multiply the magnitude of a first vector by the component of a second vector which goes along the direction of that first vector. It applies in any case like that, and it turns out that This does have several applications in physics, in different situations in physics, and it also even has applications to other fields like AI. So we have this general mathematical form for the cross product that applies to all of these cases. But to understand it, you can't just memorize this mathematical form. You have to understand at least one of its real-world meanings to see specifically how this mathematical form follows from that meaning. So let's actually address that now. Now that we understand the physical meaning of the dot product, you might be wondering, what does that physical meaning James just explained to me? What does that have to do with this simple procedure of multiplying the two x components, then adding that to multiplying the two y components, then adding that to multiplying the two z components? So how is that the same as taking a first vector and then multiplying it by the component of a second vector, which is parallel to that first vector? How are those two the same? In order to explain that, let's think of this first vector as being three vectors together. Let's think of it as the sum of its x, y, and z components. Now, remember the physical meaning here. We need to multiply this first vector, even though it's in three parts now, we need to multiply this first vector by the part of the second vector which goes in the same direction. So for the ax part, we need to multiply it by only bx, since that's the only part of b that goes in the direction of ax. Then for ay, we got to multiply that only by by, since that's the part of b which actually goes in the direction of ay. And of course, the same logic for az. So you can see that this simple formula that you probably already memorized follows from the meaning, the physical meaning of the dot product.
Can you pause it for a second?
Follows from the...
Yes, sir.
So right there, I just wanted to point out, for those who are not catching the connection between what's on line and line 3, which are indeed the same, and what's going on below that in the red and the blue. And when he says that the dot product is only applying to the component, that would be out of the two red arrows, it would be the lower red arrow, which is actually shorter, which is only moving from left to right in terms of its magnitude. That the B with the arrow of its head above the 30-degree angle red arrow is the total force applied and the total direction that it was originally applied. And that the red arrow that is horizontal connecting to the A blue one at the bottom there, that is only the horizontal. There is some vertical component to the summed B vector going up at 30 degrees, and that would be represented by an additional arrow drawn between the two arrowheads, the two red arrowheads, producing a vertical upward pointing line. That's why we're talking about cosine theta, and that is the adjacent value, which is the one that he drew, the horizontal red line, over the summed one, which is the 30-degree one, also drawn. So when we apply that to up a line, to the third line of everything that he's written there, the black and white, which is the same as the first line, you would eliminate the second and the third additives here, because in this case, by does not contribute, like he said, to the movement of a vector, the work being done. So by in this case would technically amount to 0 in regard to the component of the vector you're calculating the work being done on being horizontal, like the car on the tracks. Hope that's clear. Anyways, go right ahead. That's just something I think he's not clarifying.
You're a legend.
The idea of multiplying a first vector by the part of a second vector which goes in the direction of that first vector. Let's understand the cross product. The cross product is a way of multiplying vectors in a way that produces a third vector. It's calculated using this formula. No! Let's find out what it actually means. The cross product was invented to describe torque and other things which are similar. Torque finds how much a change in rotational motion a given force will cause. So for example, when you pull a lever, the torque is equal to the force multiplied by the distance of that force from the pivot point. To understand this principle intuitively, think about the way that normal people open a door. Now, usually we push over here as opposed to over here. Now, the reason for this is because if we push over here, the lever arm is quite long, which means that it requires less force to open the door. If you push over here, the lever arm is very short, which means it requires more force. So that's why normal people push it here.
Yeah.
Not all forces cause a change in rotation.
So what you described is what he just described with the door, essentially?
Not quite. No, this is a torque producer. This is why he's talking about cross product now instead of dot product. This is actually a different set of geometries, and this one is rotationally based instead of just Euclidean based, like the first example was.
Oh,
What I
okay.
wanted to point out is let's make this relevant to the crowd. For anybody who has studied torque in any way, in any basic mechanical way, the unit of measurement, the imperial one anyways, is the foot-pound. And is represented by those two variables we're looking at on the screen right now in the left half of the screen. The F being the pounds of force and the R in so many feet. That's why he's saying when he was pointing at the door that you have to push harder, because we're assuming a human is only capable of pushing so hard against a door that the more R you got, the more torque you're going to be able to produce with the same amount of force. Is that good?
Yes. Thank you, sir.
Okay, just before we go, just before we go, notice that this F vector that he's got applied to this lever here is not perpendicularly applied to the lever. If it were, it would be pointing downward at a 30 degree because the lever is pointed upward or downward at a 60, I guess, because it's upward at a 30.
Yeah, I see what you're saying.
There would have to be 90 degrees to be perpendicular force. Yeah? Okay, great.
Let's say that you're rotating this wrench, but you're missing a few brain cells. You might choose to push the wrench at a weird angle like this. If a force pushes on something like this, then the way to find the torque is by multiplying the length of the lever by only the component of the force that is perpendicular to the lever, since that's the only part of the force that actually causes a change in rotation. This means that the torque is actually equal to R times F times sine of theta, where theta is the angle separating the direction of the force and the direction of the lever arm. This general formula actually finds the magnitude of the cross product. We'll worry about the direction of the cross product later. So this formula is part of what the cross product means. It means take a first vector and multiply.
See that in the formula that the red A down below doesn't represent movement in the same way that the dot product calculation did. In this case, it is measured circumferentially by the total distance movement where the black arrowhead is in the diagram, going around the axis. That it would be a circumferential measurement in terms of A. Yes, right there. See, it would be spinning around, so you would measure its arc movement. Yeah, let's go.
Yep.
Apply it by the part of a second vector which is perpendicular to it. So keep torque in mind to anchor that general concept of the cross product to observation, just like I told you with work. We anchor the general mathematical concept to some specific physical meaning. And it turns out that the cross product applies to any situation where we want to multiply a first vector by a component of a second vector, which is perpendicular to it.
Do you like the way I explain things? Do you like actually understanding math and physics instead of training yourself like a monkey to repeat steps on a test? Well, then you're in luck.
No, I like monkeys,
/contact, and you can set up
Context
one-on-one
is
tutoring
everything.
sessions with me personally. All right, back
I
to the
remember
video.
thinking about that in school.
So this formula gives us the magnitude of the cross product without its direction. But the cross product of two vectors is supposed to give us a vector for some reason. Now, I'm going to show you how to find the direction of that vector first, and then I'll tell you what the hell it means after. So let's find the direction. To find the direction of the cross product, you use the right-hand rule. You start by making this gang sign. Think of it as shooting someone while flipping them off at the same time. Now, to find the direction of torque, you stick your trigger finger in the direction of the first vector. That's R in this picture. Then you stick your middle finger in the direction of the second vector. In this picture, that's F. If you do this with your right hand, then your thumb will indicate the direction of the resulting cross product, or the torque in this case. Practice this along with the picture. So again, point your trigger finger in the direction of R, your middle finger in the direction of F, and you'll find that your thumb points along the direction of that green vector. So pause the video to compare your thumb against the green vector in the picture, and note that that green vector is supposed to be kind of pointed out at you, pointed out at the screen. So in the case of this rotating nut, the force creates this torque vector, which actually goes into the screen, okay? Go ahead and confirm that with the right-hand rule. Go ahead and confirm that with the right-hand rule. And note that the green circle with the X in it, that represents a vector that's pointing into the screen. Okay, so you can give yourself a second practice session with the right-hand rule. Okay, now to explain what the hell this vector means. So why the hell is torque, a quantity representing a change in rotation, why is it represented by a vector that points in this random direction that seems to have nothing to do with the actual rotation? So the green torque vector actually represents the axis around which this force changes the rotation when it pushes along that lever.
Oh, he's moving his hand all over.
So when a force pushes on a wrench like this, it will cause rotation this way, which means rotation around the axis of that green vector pointed into the screen. So the direction of the torque vector...
I want to help you with this illusion with his hand, because he's actually using the gang sign flipping you off motion with his hand is not actually appropriate for this geometry. It is appropriate when he's describing in energy calculations the orthogonal nature between the electric and the magnetic forces in producing B field, etc. And it's in conjunction with the two-dimensional right-hand rule stuff on how you curl your fingers and your thumb shows you the axis that's being created through that flow and producing the right-hand rule. But here, if you can maybe just rewind it just a little bit so you can see his hand, I'm going to tell you what that should actually look like.
Change actually with the actual rotation.
There it is. There it is. Okay, great. Right there. Right there. Perfect. Okay, good. You see, the location of the index finger, the thing that is applying the force to his middle finger, is not in the correct orientation. It should be detached from his hand and brought towards his body in its same orientation as you see it in the screen now. It should move toward him and slightly to the right, because that's where the end of his middle finger is. So the base of his index finger would actually be touching the end of his middle finger, pointed out 90 degrees away from the axis, which is his thumb, correctly situated at the base of his middle finger, which is the thing rotating. If the index finger is the force, hopefully you follow there, that it fits the 2D diagrams that we were just shown when he started off about cross product, in that the force, the red arrow, was being applied out to the black arrowhead on the R, which is where his fingernail is on his middle finger. Hope that makes geometric sense, and that's why this analogy that he's got currently forked at the camera right here really isn't quite hitting the nail on the head.
Thank you, good sir. We'll have to come back to that one.
Yeah, we're good. Let's roll.
Direction that seems to have nothing to do with the actual rotation. So the green torque vector actually represents the axis around which this force...
See, this is what I'm showing, that the thumb is the green one coming out of the screen, the axis. The black one is his middle finger, right? The thing that's going to be rotating. And his index finger pushing the force, which would be his fingernail of his index finger, is actually touching the fingernail of his middle finger. Do you see how that is dissociated?
Yeah. Gotcha.
Right? That's why what he's doing with his goofy hand movement over there on the right is not appropriate to the mechanical analysis he's doing here. It is appropriate to the energy, to the EM analysis, which we may cover later on. You'll see it in the other videos. You know what I mean? So I hope that's clear, guys, that he's not quite hitting it on the head in terms of the geometry that he's representing with his hand. You have to take the middle, the index finger, flip it around to the outside and make the fingernails connect. And the orientation of the index finger is unchanged. And that's what you would see in the diagram here if we did surgery to his hand and disconnected his index finger. Okay, let's roll.
Around which this force changes the rotation when it pushes along that lever arm. So when a force pushes on a wrench like this, it will cause rotation this way, which means rotation around the axis of that green vector pointed into the screen. So the direction of the torque vector indicates the axis around which a force is increasing the rotation. And the direction of that vector tells us whether it's rotating clockwise or counterclockwise. If the vector points towards you, then that represents counterclockwise rotation. If it points away from you, that produces clockwise rotation. Okay, so you can remember that. In order to also figure that out, you can use this easier version of the right-hand rule I've been showing you. What you do is you swirl your fingers in the direction of the increase in rotation. And when you do, your thumb should end up pointing along the direction of the torque vector. So try this and see if you agree with my diagram. So finally, I'm going to explain this monstrosity. Let's take a moment to pick it apart. It has an x component, which depends on the y and z components of the two vectors we are multiplying or cross-producting. Then it has a y component, which depends on the x and z components of these two vectors. Then finally, it has a z component, which depends on the x and y components of the two vectors. To make this simple, let's consider a wrench and a force which are both in the xy plane. If they're both in the xy plane, then the z components of both r and f are going to be 0. And if you do the math, you find that everything other than the z component of this big equation cancels. This means that the final result of the cross product is just going to be in the z direction. Now, if you think about it, this is consistent with reality. If you have rotation around an xy plane, then that's going to produce rotation around a z-axis. So that's why, so you can start to see how this is kind of working. So let's understand how the remainder of the monstrosity follows from the physical nature of rotation. In order to do that, let's break the force into its x and y components. Let's start with the Fy component first, the y component. Fy, considered alone, creates rotation as though it's just pushing across the x component of r. It's as though that's its lever arm. Now, this produces clockwise rotation, okay, which is in the negative z direction. And if you look at the formula, you can see that that bit of torque in the formula counts as negative when Fy is negative and when Rx is positive. Now let's think of the change in rotation caused by Fx. Fx produces a torque as though it's pushing across just the y component of r this time. This will also cause a change in rotation clockwise, in the negative torque direction. This is consistent with this part of the equation since both Ry and Fx point in the positive direction. Since they point in the positive direction, you can see they're both positive, and this will end up leading to negative torque in the equation, which is consistent with the rotation you're seeing on the screen. So you can see that this part of the monstrosity follows from the basic physical meaning of the cross product. It's just a mathematization of how a force causes rotation around a certain arm. And it figures that out for vectors in 2 dimensions. Now I got good news. The rest of the monstrosity is understood using this same logic, but we just have to add 2 more directions to the situation to understand the whole thing. So imagine you're in your lair pondering your orb one Sunday morning. That's what I usually do on a Sunday morning. And let's say you make the floating orb spin by brushing your finger past it gently like this, making a force like what you see in the picture. To understand the rotation this will cause, we're going to think of a lever arm extending from the center of the sphere out towards the spot where the finger brushes against the surface. This is going to cause an increase in rotation, or a torque, along this diagonal axis. Notice how the force and lever arm vectors in this diagram have x, y, and z components this time. Now, all the monstrosity in all of its details is trying to tell us is that the y and x components of R and F, they produce a torque in the z direction, just like last time. But there's also y and z components of R and F, and they produce torque in the x direction. Okay, that's this part of the equation. Then the x and z components produce torque in the y direction. All 3 of these parts are calculated the same way I showed you in the last example, and all 3 of these components add up to produce a torque which has an x, y, and z component. And so that's why the torque is diagonal in the diagram. So that is my explanation of the dot product and cross product. A dot product finds a scalar by multiplying a first vector by the part of a second vector which is parallel to that first vector. The cross product produces a vector based on multiplying a first vector by the component of a second vector which is perpendicular to that first vector. If you ever forget these definitions or get confused about the general concept of dot product or cross product, go back to these physical meanings I just taught you. Think about work or rotation. If you liked this explanation, please hit like and subscribe. You can visit my channel to
One other thing I kind of have a head scratch about, if you go back about 30 seconds in his video there, the last formula he showed. Keep going back. No, just before that. It's the one with the orb and the AB and the tau and stuff. Coming back. There it is. That's it right there. Okay. So I'm scratching my head here because he's using A and B below, but R and F above. That struck me as kind of strange. Big disconnect there. Anyways, carry on.
Made a goof. So basically it's about multiplying parallel and perpendicular forces to describe how much, force is going to be applied with respect to like some radial distance.
Either linearly or radially in this case, the cross, yeah.
Cool. Badass, man. So that's the physical meaning of cross products and dot products. Stone, that was an awesome breakdown and analysis, bro, with such short notice too. Thank you very much.
My pleasure.
All right, so now we're going to move on to what is actually waving. Oh, did anyone have any questions or anything before we move on? All right.
The key to the next revolution in physics has been hiding in plain sight for over a century. Let's find out what that key is here on Inductica. Imagine a glass jar with a bell in it. If you shake the jar, you'll hear the bell ring. If you pump the air out of the jar, you will no longer hear it ring. This is because sound is a wave consisting of expansions and compressions of air. Remove the air and there's nothing to expand and to compress. Now here's where it gets interesting. Light is also a wave, yet we're still able to see the bell after the air is sucked out. Light waves are still reaching us through the air. If light is not a wave of air, though, then what's waving? Clearly there must be something left in the jar, even after we've apparently removed everything from it. Whatever this something is, it must be everywhere, since light can travel everywhere. even in the vast emptiness between the stars. This stuff, whatever it is, has historically been called the ether. Now, you may be aware of certain arguments against the ether, and I'll address them in a moment, but for now, let me show you just how important this really is. To do that, I'm going to give you a brief survey of all of the physical phenomena that we're aware of so far. First, observations of quantum phenomena have shown us that the particles that make up matter, say protons, neutrons, electrons, are all somehow wave-like, or they have a field-type nature. So for example, if you shoot electrons through a pair of slits, they will interact with one another in the same way that waves do. Number two, the strong, weak, and electromagnetic interactions, certain forces between matter, are also mediated by particles. Photons mediate the electromagnetic force, gluons mediate the strong force, etc. These particles also have a wave-like or field-like nature. Thirdly, gravity is also a field, creating an attractive force as well as changing length and time measurements. And as the LIGO experiment recently discovered, there can even be waves of gravitation. This short but broad list exhausts all of physics.
Let's all take a brief moment to chuckle.
I had a problem with a few things he's said so far, starting with number one. This matter is a quantum field and is how you define a quantum object. You're always invoking mass. But, you know, light is not matter, is the problem with mainstream physics. And nobody seems to want to acknowledge that. He says when you shoot a pair of electrons through two slits, well, are you serious? This is not something anybody in mainstream has ever actually observed. Looked at a single, quote, electron blow through a slit. I mean, it's just never happened on the terms that he is presuming to lay down here. And again, this thing about gravity being a field, when we hear Dr. Bennett talk about the lab frame a lot. Unfortunately, we puny little plebeian humans down here, that's the only frame we have. That when we talk about the ether and the things that it's doing to light, we have no comparison. There is no way to manipulate that variable. So all of this is just assumption on top of assumption on top of assumption, and this is the kind of trouble we get into in the mainstream. Go ahead.
Physics. All known physical phenomena are simply combinations of these fields. A hydrogen atom, for example, is a proton field surrounded by an electron field. So apparently, all physical phenomena are fields. Now, what is a field? A field is a property with different quantities at different locations. For example, the electromagnetic field is a property which determines how much force a charged object will experience at a given location. So a field's a property. Now, think of it this way. A property must be a property of something. Nothing doesn't have properties, so there must be something, some medium that exists everywhere. That's the argument for the ether. The existence of fields requires a medium. Just as sound is a changing property of air, the pressure, these different fields are changing properties of the ether. Maybe the real path towards a grand unifying theory is to understand the nature of the ether and how it gives rise to these different fields. Now, many of you are probably saying, hold up, James. Before you get carried away, didn't the Michelson-Morley experiment disprove the ether? No. Let me show you. For those of you unfamiliar, the Michelson-Morley experiment was an ingenious experiment conducted in 1887 to measure the speed the Earth traveled through the ether. In this experiment, light was shot out of this emitter and passed through a beam splitter. A beam splitter is an optical device which allows half of the light to pass through it, while the other half is reflected. This will create two separate beams. Each of these two beams is reflected off of a mirror so that it's then brought back to the beam splitter. Now, once this happens, part of beam B is reflected off the beam splitter, while part of beam A is transmitted through it, which brings A and B together at the detector at the bottom of the diagram. Now, because these beams are waves, they will cancel and strengthen one another in a pattern which looks like this when they overlap at the detector. Now, the Earth moves really fast around the sun. So the Earth should be moving through the ether, which would cause an ether wind to blow through this setup. Now, to keep things simple, let's say that the ether wind is blowing along the direction of beam B. If this were the case, then beam B would be traveling upwind at first, then downwind after it reflects off that mirror on the right. Since light is a wave of the ether, beam B would be slowed down as it moves upwind and sped up as it moves downwind. Now, doing the math, this all has the overall effect of slowing down beam B. So overall, going back and forth, it takes longer as a result of this wind. Now, after recording...
Yeah, slight point of contention there. Their interpretation was that the light would be dragged through a stationary ether, not that it was a wind, like going, you know, because they were on the stationary ether grind. So just for some slight clarification there.
Recording the pattern in the detector, Michelson and Morley then rotated the table that the experiment was mounted on. This would cause a change in the speed of both A and B, since each would now be going in a different direction with respect to the ether wind. This will make A and B each be in a different part of their wave cycle by the time they reach the detector, which will cause a measurable difference in the pattern they make when they combine at that detector. In this way, Michelson-Morley planned on measuring the speed of the ether wind. This experiment required painstaking precision.
No. They were trying to measure... They were trying to measure the velocity of Earth with respect to a stationary ether, not measure an ether wind. So
That's some bullshit.
Michelson actually suffered a nervous breakdown while trying to conduct the experiment, and after all of this effort, they detected nothing. Michelson and Morley tried a number of tricks, but they couldn't get this apparatus to detect motion through the ether. Modern physicists...
That guy didn't read the paper.
I know, dude. That's so sad.
As proof,
he just said it right there, right?
Wow.
However, this simply isn't the case. First, and most importantly, this experiment doesn't explain how waves can exist.
Oh yeah, he for real didn't. Well, real quick, gotta do it justice. Shout out to my boy Michelson out there in the streets.
I want to back up to something even more fundamental than that as soon as you're done. Let me know.
Yes, sir. So the actual measurements here are 0.04 of a fringe, which corresponds to 6 kilometers a second if you're going to take that as a velocity measurement. And their their error margin was 0.002 of a fringe, corresponding to 2 kilometers a second. So they were outside of their error margin, and they expected 0.05 of a fringe, which would correspond to 30 kilometers a second. And we're here looking at the data plotted out from this graph where they took the measurements here, or from the data where they took the measurements, and then we have the graph here. So their expected values for the fringe displacement with respect to the time of day that they were taking the measurement, where they would be in alignment, parallel or perpendicular to that direction of motion. And then with respect to the interferometer's orientation here, which is why they have these numbers here as they rotated it to see if they would make them, or, to see if when it's aligned with those directions of assumed motion based on sidereal time, and they would get like minimum and maximum fringes. So that's what they were doing there. So that's what we're looking at here for this. And did you have anything to add, Stone?
Yeah, I wanted to go back to when he was talking about a field. What is a field? And he said a field is a property. And that's not true at all in the base nomenclature assessment of what he's saying. The field something has is actually the property of the thing. The field is the property of the thing itself. The field itself, when you only describe it alone in the context of itself, a field is a gradient. Typically, we deal with radiative bodies in everything from gravitational math to black body radiation math to everything you talk about with light emission math, other than when you're talking about coherent beams like lasers. It is always a radiative aspect to something. Like magnetism is also, it is done radially. That we always talk about this field in terms of a radial source, a point source. Well, what that does is it creates a radial gradient away from that point, being the highest value of force, depending on what you're looking at, that you would experience being so close to the object. That as you go farther from the object, you feel less of the force that that object would assert on you, being charged in this case of light, according to R. That a field is a gradient of potential. Hope that makes sense. Go back to it.
Sorry, I was taking notes. Dude, I agree. That great explanation.
Thank you.
Where nothing is waving. So I want you to keep that firmly in mind, that that's the ultimate argument for the ether, is that something has to be waving. But second, it's worth noting that the physicist Heinrich Lorentz was actually able to explain this negative result using the ether. Using Maxwell's equations of electricity and magnetism, Lorentz calculated that the electromagnetic field produced by the atomic nucleus would change depending on the nucleus's state of motion. This change in the field of the nucleus would change the circular orbit of the electron into this elliptical smashed orbit like this. Now, since Michelson and Morley's table is of course made out of atoms, this would cause the table to get smashed by this exact same amount, shortening the distance that beam B must travel. Now, upon doing the calculations, Lorentz found that the change in length of the table along the direction of the ether motion would shorten the path of the beam just enough to cancel the amount that the ether wind would slow that beam down, making it appear to be going the same.
Yeah, 1 second, dog. This is extremely.
Let's put the brakes on this hogwash.
Dude.
Didn't he come up with that equation to explain this would have to happen if that's what you wanted? It wasn't saying this was happening.
Yep, exactly. So check this out. We just went over the actual physical measurements and they were outside of their error tolerance. So, they were valid at the time. And this is why they had to redefine all of physics over this. And they only present us with this amount of data here. They obviously took more measurements and we're only getting this like little sample size here. And they're just like, oh yeah, we're going to go ahead and redefine all of physics over this. But anyway, so specifically stating here, going back to Lorentz applying his theories, dude, real quick, we're going to check out the preface here from Michelson explaining Airy's failure to measure the heliocentric velocity using a water-filled telescope with respect to the predicted correction angle for that velocity. Now, they had a problem here with the undulatory theory, so light being a wave, where they said that the ether had to, the stationary ether somehow had to become mobile in the telescope. And then if you believe that light is a particle, the light has to accelerate in the water, which violates conservation of energy and momentum. It makes no sense. It's it's not a tenable position. And so at their time, the explanations for this was they didn't have one, and so they have to look at these measurements as a zero value, right? So Airy's actually had to tilt his telescope by 0.8 arc seconds, but they say, oh, that's experimental error, it's a null or whatever, right? So they're rounding that to a zero. Your boy Lorentz comes in and says, link contraction, time dilation. So that was what was just put forward with those equations. Now, if you take the values from Michelson-Morley measured here at 6 kilometers a second, you can't use link contraction and time dilation. So what this guy is going to go on to explain here is that when he's referring to Stokes' theory and Fresnel's explanation for why there was no tilt angle for an Aries failure, they said, they proposed that the stationary ether somehow became mobile and carried the light in the opposite direction of motion. And it's like, that's a cool ad hoc explanation, but we'll roll with that since we don't have anything better. And we're all Copernican lads and we're Keplerian and Newtonian dynamic out of our minds. So if you were to use link contraction and time dilation on this, it has to be a null result. It has to be a zero value. That's why the important part of Michelson-Morley is, as told by the mainstream, is that it was a null. They measured nothing. They didn't get a measurement, and that's not true. We're looking right here at the measured values, and then of course this was repeated by other people, but we're not going to segue into a full interferometry diatribe. But this is just for absolute clarity on the theories and the measurements at hand.
Okay, so right there when he's talking about Lorentz and he squishes his atom to the side here, and he tells us that that's because of this formula, which you see underneath, 1 over the root of 1 minus v squared over c squared. This reminds me directly, and I recommend everybody go back and review the video that I produced on Einstein a month or two ago now. Because I apparently appear to be the only one to take real world measured figure and apply it to the formulae and see what's really up. You don't need to play it right now, but this is where you find it. Alan is showing it to you. It's a couple thoughts about Einstein. When we look at the significant figures of Michelson-Morley, like he was showing in that diagram right there with the squashed atom and the table spinning, we're looking at significant figures of 30 kilometers per second and a fifth of that, around 6 kilometers per second. What they claim to have, quote, measured by the interference fringe patterns produced on their apparatus. Regardless of the direction they spin it, they find an orientation to that suggested influence on light's velocity. Okay, great. But here comes Lorentz and says, oh no, it's because you're moving so fast that it doesn't actually look like you're moving at all. And you will see, I don't know if it's right in here or underneath another paper we were just looking at, where it suggested 3/5 of the speed of light is the speed at which something is taking place. Well, no, that's actually not even close. It's not even, it's several order of magnitudes away from what we're talking about in terms of our own measurement, assuming that we should get a measurement of 30 kilometers per second or 6 kilometers per second. Hey, everybody, that's the v squared. The c squared is 300,000 kilometers per second. And when you plug the figures in, you approach zero on how totally insignificant they are, and in turn, how significant this influence would be on the measurement. That in order for, like, when we look at this diagram here, and we show an ellipse on the right side that is now only, say, 75% as wide as the circle on the left, we're assuming inherently that somehow there is 25% length contraction going on here. Well, when you look at that formula and you plot it out, you find that you don't get 25% length contraction until you are doing 99.992648% of C, as you're doing 299 plus thousand kilometers per second for that influence to be seen at all affecting your measurement. That at even 3/5 of light speed, if that's how fast this table were going before they changed it to this orientation or that orientation, and look at the interference fringe caught impacted by the change speed of light, it's just unbelievably insignificant in terms of trying to derive an explanatory solution for why they got these measurements and how they can argue that they were null because of this phenomenon. I hope that's clear. But yeah, any other questions, by all means ask, and I'll try and restate it. But I got a major problem with that.
No, well said.
Same speed as the unaffected beam. Now today, of course, we know
I don't know
that
if you guys
length-
want to hear from me, but I just want to point out that, yeah, it's an extremely small effect. And that's, of course, why they needed why Michelson needed to invent the Michelson interferometer in order to detect it. And the point of the 6 kilometers per second thing is that was the sensitivity of their ability to see a change of 6 kilometers per second. So by looking at doing the experiment and then doing it again 6 months later when the Earth was moving at 60 kilometers per second in the opposite direction and seeing no result to a 6 kilometer per second level, they were faced with the fact that they couldn't detect an ether that they knew existed. Right? All physicists at the time were sure that there had to be an ether, and the point of this experiment wasn't to determine whether or not there was an ether. It was to find our velocity through it, and the experiment was clearly sensitive enough to detect it, and yet it didn't. So then the question became, well, maybe is the ether being dragged by the Earth? Is the fact that we don't detect any ether wind just the result of the fact that the Earth drags it with the Earth? And a lot of people worked on that for a long time. That's why the telescope with water thing, I just can't remember the name. And other experiments, aberration of light, people looked at all those things. All of those ruled out the idea that the ether was being dragged with the Earth. So Lorentz's idea was an attempt to show how he was attempting to say, no, there is an ether, but it can't be detected. That was the purpose of that we can't, the Michelson interferometer can't detect it for that reason. Basically, what Einstein said was that it doesn't make sense to come up with a theory that says that something exists but it can't be detected. He said, what if we just see the implications of assuming, as the evidence seems to show, that there just isn't an ether, and that the speed of light is the same for all observers regardless. And that's where the theory of relativity came from.
Yeah, so you inverted it back to it being about a test of the ether and not being able to detect it. But what can be equally said about that is that it's a test of Earth's velocity, as you accurately stated before you changed it up. Now, it's the assumption.
No, that's right. I don't disagree with.
It's the assumption of a velocity that can't be detected, that you believe in, rather than an ether. Now, our position, or not ours, I'm speaking for myself actually. My position is that these velocity measurements, the 6 kilometers a second, is a valid measurement of velocity with respect to a stationary Earth. And there's an ether wind that is following sidereal time. So you can measure the minimum and maximum fluctuations throughout the day. And when you plot that with sidereal time, you'll get the corresponding sine wave to show that correlation. So these experiments were actually continued on by Dayton Miller for about 25 years, and he reproduced these measurements and found a sidereal periodicity as well as an annular periodicity where the fringe shift patterns reach the minimum and maximum dimensions. So showing a correspondence to not only the position of the stars throughout the year, but also the position of the sun.
Alrighty, back to the video.
Yep. So just real quick, confirming there's an east-west bias for the speed of light. It's not isotropic. It's measured as anisotropic. And then, of course, when you get into a closed loop interferometer with Michelson-Gale, they're like, oh, we'll acknowledge this anisotropic, measurement, but the Michelson-Morley interferometer, because it's just a single right angle, that's a special type of interferometer, and we'll just ignore that and call whatever it measures a zero. If you have anything you want to add to that, John, before we move on, feel free.
No, I don't really. I mean, all I'll say is that I understand. I know about Dayton Miller's, extended experiments, and I also know that the physics community has decided that those measurements are not valid for reasons that I won't be able to explain to you. I don't know. I mean, I probably should look at that myself. But
Oh, you're good. I can break it
so
down
all I want
for
to
you real
say is,
quick.
I guess what I really want to say is, I don't have any trouble with the tone of the discussion here, or I think these are all very legitimate questions to be asking, because it was the case that physics community in the late 1800s, there was no question about whether the ether existed. The only question was, how fast is it moving? How fast are we moving through it, presumably? Now, you could take, of course, the opposite view if you believe the physics community clearly was committed to a non-geocentric model at that point. And that's fine too, right? You can take whatever you want from that. But the results of all of that were, as I said before, Einstein just basically taking the results of the Michelson-Morley experiment seriously and saying, well, what if we just simply accept the apparent fact that there is no ether? And he came up with a theory based on that. And that theory's been fantastically successful. Now you can say, well, maybe an equivalent theory of some kind would be equally successful. And of course, everybody's always free to come up with other theories that do that. But it's not deniable that the special theory of relativity and then the general theory of relativity, which has been our theory of gravity now for 100 years, has been fantastically successful.
Without having to cite them specifically, would point you to dozens and dozens and dozens of physicists, even at the time, who were in opposition to all of this Jedi mind trick.
Well, especially at the time, yeah.
All right. Well, real quick.
Ergo, I would not refer to it as tremendously successful when a large predominance of the community are rejecting it openly.
Oh, well, that's not true. I mean, the theory of relativity is roundly accepted in the physics community. You'll find precious few. Oh no, that's just a fact.
No, John.
If you're going to try to tell me
arrogance.
No.
That is academic arrogance.
Okay. Fine.
All right, lads. Let's settle down. So
one real quick comment. Is that okay?
Yeah, absolutely, Lily. What's up?
Well, I noticed that, we let John speak without being interrupted earlier, Alan. And then I want to congratulate John because he caught himself interrupting you. When we have the recording, you can verify that. So I think he is learning. He's making some progress about not interrupting.
Nice.
Yay.
I did notice that. Well done. I admire the mutual respect. So real quick to catch you up on the mainstream narrative of dismissing Miller's work. His former lab assistant, Robert Shanklin, who 14 years after Miller died and inherited all of Miller's work before he died, selectively went through 3 portions of his data to do an analysis on to, disprove it, because when Miller did his analysis, he came up with that sidereal and annular periodicity. So what Shanklin did was he just pulled out 2 samples where the temperature, where seasonal effects were like at the greatest for heat. And then he took one sample from his controls, which were unpublished, which aren't even, it's not even valid to do, and then present it as if that was part of what he was doing, where he was purposely trying to see how much heat it would take to, like how much that would affect it. So he took those and said, well, look, Miller didn't know about temperature differentials, and, we can just hand wave dismiss his work. So, and then after that, he was heavily promoted in the mainstream, got exclusive interviews with Einstein, and was one of the boys or whatever, right? And then the most recent refutation comes from this guy. His name is Thomas Roberts, in 2006, which is like the bigger one that people appeal to, because this guy did a discrete Fourier transfer or transform analysis on it, right? And he determined that Miller was just measuring noise, right? But what he says here, and so keep in mind, right, the data that this guy analyzed, Thomas, right? What he analyzed, Shanklin destroyed all of Miller's data except for like a little bit of it. So we don't have access of it. We've never seen any of the raw original stuff. Actually, we've seen like bits and pieces of it, but nothing that that this guy, we have no idea, right? So he just determines that there was bad data, and then he throws it out in his analysis. Now, we don't know what he doesn't mention in this paper when you get a chance to go through it. He never mentions what he throws out or what his criteria was for bad data. So, and then he says, dude, posthumously, Miller is now experiencing every experimenter's nightmare. The standard analysis algorithm used by himself and all his contemporaries had a serious flaw not explicable for many decades. And they caused the noise in the apparatus to perfectly mimic the signature of a real signal. Oh, no way, dude. He was just measuring noise that perfectly mimicked a real signal. And then when you throw out that, the real signal and do the analysis, suddenly there's not, like, dude, this is, have a good read on it. It's very, I don't know if you take a look.
Can I ask a quick question?
Absolutely.
I assume that the focus on this comes. I don't know. I'm not sure how much this bears on a flat Earth kind of a perspective, but I'm assuming it bears on a geocentric perspective. And I don't know the answer to this question. I could guess at it. I don't think Dayton Miller believed in geocentrism. Am I wrong about that?
No, he did not believe in geocentrism. In fact, when he plotted his minimum and maximum dimensions that correspond to the equinoxes, the way that he modeled it out, the measurements themselves, like if they were at the 30 kilometer per second threshold, would be significant evidence for the heliocentric model. But because the values were so different, obviously nobody could acknowledge the validity of them, so they have to say there's zero. But he always stated that he couldn't provide an explanation as to why the measurements were 6 kilometers a second, and that he assumed that from a greater galactic speed, that by the time it gets to Earth, it's only that amount.
As an addendum,
it would seem.
Sorry, just to fill it in for you. For me, the most striking quote Miller ever made was near the end of his life, or near the end of his experimental life, when he said, "I tried so hard all this time to get zero, and I never did."
Yeah, and it would seem to me, I guess it would seem to me that if he always got small values, that would lead him in the direction of geocentrism.
Well, my argument.
Well, I'm not so sure 1/5 is small. 1/5 of expected.
Well, I mean, my point is
that's small.
I'm saying that because anything less than 30 kilometers per second suggests that basically the ether is kind of moving with the solar system, and if it's moving with the solar system, why not the Earth or something? I think you would expect an ether wind to be 10,000 kilometers per second, or some significant fraction of the speed of light, at least something way bigger than the speed that the Earth orbits the sun with. And so when you get speeds much less than that, that would seem to argue for geocentrism.
You point to one explanation as if that would be the only explanation. What about the explanation that the Globee model is simply totally incorrect?
Well, I'm not sure what you mean by that. I mean, you mean that it's not even a globe. I don't understand why it would mean it's not a globe. I think it's only a question of whether it's geocentric
I'm-
or not, right?
Maybe I used the wrong adjective. What I really meant was the heliocentric model. The galaxies and everything blasting out of the Big Bang way out
Right.
through space with all
That's what
with
I'm
no
saying.
entropy in
That's what I'm
sight,
saying.
with a hope for dark matter and dark energy. Maybe all of that as an explanation for why he got the measurements that he did. The explanation might be, well, shit, maybe everything about that model is wrong.
Sure. No, I think if I didn't make myself clear, I think that's what I was saying, that measurements like his, if he actually found that there was motion, but that it was small, that would be very weird, right? And you'd have to come up with some, at least kind of,
Yeah.
when I say heliocentric, I mean by that, physicists don't think that the universe is heliocentric, right? That's a solar system model. They don't think there is a center to the universe. The question is, and so seeing velocities that are so small do suggest that the solar system is a special place, and that alone is enough to cast serious doubt, on current models. At the time of the Michelson-Morley experiment, we didn't know that there were other galaxies. We didn't know it. We had very little understanding of the universe.
I think that's still the case.
So the Copernican principle is that
I
the
do-
Earth has no special place, and the big part of their model, following Kepler's laws, and then the assertion of Newtonian dynamics, apply to them with G m r squared. They have to have a specific, they were committed to a specific cosmology, and as a member of the Royal Society, I don't think he interpreted it as as a geocentric position to be viable because of his philosophical beliefs, or maybe he felt that he wouldn't get published but that's just speculation or whatever at that point. But they do all have the Copernican principle as their philosophy for the baseline. So the problem then becomes, how do you acknowledge these measurements as first order velocity measurements that don't correspond, that would confirm Newtonian dynamics?
Real quick, I have a request. Sorry. John, if there's anything that you have to say that we can find on Google, I would prefer not to hear it, because I think I speak for the audience when I say that we would all rather hear the voices that have been silenced, like those scores of scientists during even the era of all these experiments. I'm sure everybody's seen that famous photo of the scientists in Germany that were refuting Einstein's theories. We want to hear all the alternative stuff. Everything when you go into these long diatribes, it's basically, we can find it on Google. So I just for the sake of the audience, our time is precious. So we want to hear, unless you have some original thoughts or you are giving a voice to the silenced, I would prefer not to hear from you if it's just, Google stuff.
Nothing personal.
Dude, Lily, you're incredible. He left.
Way to set the standard.
All right. So back to the old, dude, that was a long break.
Right. Back to the Globy. Yes.
All right. Back to the old video here. So the question of physicists aren't asking. Here we go.
Contraction is real. Contrary to the normal narrative that
Is your volume up? Thank you.
going the same speed as the unaffected beam. Now today, of course, we know that length contraction is real. Contrary to the normal narrative that Michelson-Morley disproves the ether, Lorentz actually discovered length contraction before Einstein by using the ether to explain the Michelson-Morley experiment. So if Lorentz discovered length contraction, then why is Einstein the one who's remembered for it? Einstein ditched the ether and instead derived length contraction from the assumption that light is measured to be the same speed for all non-accelerating observers, regardless of their speed. The way this assumption is usually explained is that if you take two observers, one stationary, another on board a spaceship traveling at half the speed of light, and the moving observer shines a flashlight, then that moving observer will measure the light as running away from him at c, the speed of light. Now, common sense would then tell you that the stationary observer would observe the light moving at 1.5 times the speed of light. But Einstein's assumption states that the stationary observer will also observe the speed of light to be going at the same speed as the moving observer, that is c. Now, the way Einstein explains length contraction is by saying that this strange way that light is measured by different observers to be going the same speeds then requires those different observers to also measure different lengths. That's Einstein's way of explaining it, with this assumption that the speed of light is always measured the same speed.
So
Snicker.
So yeah, so remember Einstein says, no ether, right? Like no physical mechanism, no physical medium. And then he makes time and space a function of velocity squared over c squared. Just length contraction and time dilation. And then he's saying that, the relative motion in reality, because of this transformation you can do, that relative motion is true dynamically, even though with something as basic as Doppler shift, you can tell if an observer is an inertial observer versus an observer moving at a constant velocity.
Take a closer look at that diagram too. See the big arrow pointing to the v equals c over 2? That is supposed to represent the speed at which that little spaceship is traveling relative to the, quote, stationary observer, which actually invokes absolute space, which is completely counter to the philosophy of anything relativistic. But back to my other quantificational point, that when you're only going half the speed of light, v squared over c squared, it's still coming to zero in terms of the amount of difference you're going to measure between those two observers. Diddly freaking squat.
Yes, sir. And that diddly squat will be reciprocal.
Speed by different observers. So both Einstein and Lorentz's theories are consistent with experiments. But Einstein's theory was accepted on the basis that it made fewer assumptions. Instead of positing that length contraction and duration dilation are caused by a difference in motion through an ether that we can't even measure the speed of, all of the interesting effects of what is now known as special relativity could simply be deduced from these two postulates of Einstein's: that the laws of physics are the same for all non-accelerating observers, and that all of these observers measure the same speed of light. So the ether was never disproven. Physicists simply preferred Einstein's explanation, that these effects were the result of the speed of light being measured as the same for all observers. But
keep in mind, they all agreed while keeping the velocity measurement at a zero. So like ignoring the measurement and the subsequent measurements and the history of them, which falsify their model entirely. This is one of the greatest scientific frauds in the history of science.
Big time.
But let's remember, the ether is not just a hypothesis. Its existence is already proven by the existence of fields. Remember, fields are a property at a particular location, and these properties can't be properties of nothing. Now, because they realize this on some level, modern physicists actually attribute these fields to something they call the quantum vacuum. But we got to remember, the word vacuum means nothing, and it's not nothing. It's something. It has properties. Now, this isn't just a matter of semantics. So long as we say that these fields are properties of the vacuum, properties of nothing, then we can't ask what that nothing is. Nothing isn't something we can ask about. Alternatively, if we decide to call it an ether, if we decide to name it as something, now we can ask, what properties of this something, of this ether, cause it to carry these fields? Now, in an attempt to answer this question, we can make hypotheses about how the ether might tie these different fields together, might tie all of physical phenomena together. Here are a few hypotheses that you might be able to make right off the bat. Creation and annihilation interactions of quantum particles show us that quantum fields are such that when they combine, they can create other quantum fields.
All right, quick preface here. When experimental measurement didn't match theoretical prediction, Feynman diagrams were introduced to explain the discrepancy based off of theoretical interactions of virtual particles, which come into existence and then self-annihilate through collisions, etc. And this is supposed to be like a dynamic explanation as to why the measurements didn't meet experimental prediction. And none of this interpretation has any physical value. Everything in quantum mechanics starts with a wave equation, and all mutual exclusive experiments, so-called, like Compton scattering and the Stern-Gerlach experiment, can be explained with the classical effects, as well as the Casimir effect. A field of math doesn't explain a physical pressure difference in energy fluctuations that are measured, right? You can't abstract a physical measurement and say that math is responsible for it as a mechanism. That's preposterous. Did you want to add anything?
So they just developed new math on the fly. Every time they discovered new weird things, they discovered new math to go with those weird things. Interesting how that reification goes.
Indubitably.
So, for example, an electron and positron can be combined to create a photon. Conversely, photons of high energy can often change into an electron-positron pair in certain circumstances. This tells us, think about what this means for the ether. If all of these things are an ether...
Yeah, so right here we're actually looking at the Compton scattering. He just doesn't have the angle. But yeah, you can reduce the Compton equation down to just a wave equation with respect to the angle, and that'll give you the changed wavelength.
Waving, then this tells us that the ether can wave in different ways. It can wave in an electron way, a positron way, a photon way, and some of these manners of waving can give rise to other manners of waving. So perhaps these different conversions among these different waves will teach us something about the underlying properties of the medium which carries them. What properties might the medium have if it's able to wave in these different ways? And if some of these ways can give rise to other ways of waving? Let's turn our attention to gravity, which is the odd man out among the physical phenomena. Gravity, of course, bends the path of both light and matter. Now think about this. If light and matter are just waves in the ether, then perhaps gravitation is a bending, not of some abstract space-time, but of a very physical ether. If gravity is a bending of the ether itself, it would explain why it causes the path of ether waves, light and matter, to change their path. Perhaps this is the reason that physicists have been unable to quantize gravity for the last century. Perhaps it's because gravity is not a quantum field to begin with. Perhaps the quantum fields are some property of the ether, which is able to vary in the more and the less, it's able to wave, and gravity is a bending of the ether itself. Now, I have to emphasize, all of these are just both of these are just hypotheses.
Take the video back to that diagram. Go back about 5 seconds, 10 seconds. There you go. Okay, that diagram up top on the left is geometric fraud. And it is so unbelievably exaggerated. It's just mind-blowing that they would even draw it. Okay, in your own mind, draw a straight line between the actual star location and the location of the observer supposedly down there in the bottom right on Earth. Goes nowhere near this star, this sun that's coming around. which is supposed to be the same thing as the thing that we're looking at farther away. You know what I mean? That it is so hideously bent that, like, why aren't we seeing it on the below side? Why aren't we seeing direct line of sight of that star? And the answer is because nobody has ever measured this amount of light deflection around the sun. That we do not experience that kind of warping of what we see in the sky with proximity to the sun. And frankly, it's even hard to measure it in any other time other than a solar eclipse because it's daytime. You can't see the stars anyways. Hope that makes sense. So the moon would also come into play in this diagram, far closer to the Earth in the bottom right. This is what I mean about the idiocy of that diagram. All right. Oh, lower left diagram, again, that is not the elliptical shape of the Earth going around the sun. It's only like 1.5% away from perfectly circular, as opposed to that hideous ellipse you're looking at right there, which is like so totally not representative of what they claim is going on in our solar system. So 2 strikes on this guy in the same frame. All right, let's roll.
Absolutely, Stone. That's why you're head of quality assurance.
To wave, and gravity is a bending of the ether itself, just hypotheses. But the point of presenting them to you is that thinking about the actual medium opens doors towards a deeper understanding of these phenomena. The true purpose and the real power of science is the ability to identify and control hidden facts which influence the phenomena around us. Early chemists were not content to simply document the different ways that chemicals can change. They went on to discover the underlying reason that they change, because they are atoms that join into molecules. This deep knowledge has enabled us to enjoy custom materials, such as specialized polymers in cars, the semiconductors in computers, and catalysts, which speed the production of life-saving drugs. All of these are novel combinations of chemicals which would never have been discovered without understanding the fundamental way chemicals combine as atoms and molecules. Just as the chemists of the late 1700s were right to look for the underlying nature of chemical reactions, physicists today must seek to understand the medium which carries quantum and gravitational fields. If the atomic theory gave us mastery over matter, then just imagine what kinds of powers we will enjoy once we understand the medium which plays a role in all physical phenomena. What other evidence can we gather about the ether? What special methods will be needed to discover the nature of this elusive yet ubiquitous medium? These are some of the questions Inductica will answer in further videos. So hit subscribe to join me on that journey. I want to give a special shout out to Bruce, who generally supports Inductica at $50 a month. To support the project, just go to patreon.com/Inductica and make a pledge to receive donor-exclusive lectures. Thanks for watching.
Good on you, Brace.
Nice, dude. We got one more. Another 14-minuter. So why the magnetic force is perpendicular to the magnetic field.
Sometimes when studying physics, you get really frustrated when you have what seems like a simple question and no one wants to give you a straight answer. Explain to me why the magnetic force is perpendicular to the magnetic field, or I will kill you. Don't dumb it down or I will kill you. If you say F equals Q V cross B without explaining why, I will kill you. This is a slight exaggeration of the attitude some of my tutoring students in physics have. Because physics professors tend to think in terms of math rather than physical cause and effect relationships, their answers to questions like these are almost always unsatisfying. To add insult to injury, the non-answers that they give are often accompanied with a hint of contempt, like maybe you're only asking because you weren't really paying attention. Now, to answer this gentleman's question, we will first have to learn something deep about the meaning of fields. This will in turn highlight a path that we might use in the future to go beyond fields and to discover the mysteries that lie beneath them. All of that is coming up here on Inductica. So what exactly is this guy screaming about? Let's review. In general, a magnet won't push on a charged object. For some reason, it will only push on that charged object if it's moving with respect to the magnet. Now, to make things stranger, if the magnet puts a force on the charge, then the magnetic force is actually always perpendicular to the magnetic field, just as in this diagram. The way to find the direction of this force is to use the second right-hand rule.
Here
to do
it
that, you
comes.
make this gang sign. It's like shooting someone.
Put your gang signs up, lads and ladettes. Represent.
This time we don't have to pull a finger out.
While flipping them off at the same time. And then what you do is you stick your trigger finger in the direction of the velocity. Then rotate your hand so that your middle finger is in the direction of the magnetic field. So you can see I've done that here. Once you do this, your thumb points in the direction of the magnetic force. So you can see my thumb is pointing in the same direction as the green arrow here. For some reason, this bizarre procedure gives you the direction of the magnetic force. To calculate the quantity and direction of this force, you use the cross product, which you can learn more about in a previous video of mine, which is linked in the description. Now, this guy is angry because it's not at all clear why a field that goes in one direction would cause a force which goes in this completely different direction. Typically, when you ask this question in a physics class, the professor will get a little impatient and he'll just repeat the cross product to you, or he'll repeat the right-hand rule. He won't get the essence of the question. At this point, a lot of YouTube channels would say, let's provide an intuitive explanation of how this works. I'm not going to give that to you though. I don't really believe in intuitive explanations. Because what does intuitive mean? Intuitive means in agreement with your intuitions or feelings. But our feelings aren't always right. Our feelings are simply the result of past experiences. And there's no rule that the magnetic force should be anything like our past experiences. After all, something simple in physics like Newton's first law, the law that all objects maintain their motion in an absence of force, is actually counterintuitive to everyone, since everyone basically grew up around frictional forces everywhere. So often intuitive explanations oversimplify or dumb it down. If I dumb it down, then this student will fudging kill me. Now, what we really want, and what this poor student is actually hungry for, is a physical understanding. An understanding of the actual cause and effect relationships which make a magnetic field push on a charge in this weird direction. A big reason that this feels so mysterious is that a lot of people think of magnetic fields as these disembodied lines of force that just exist in space. As a result, you're weirded out when the force isn't in the same direction as the field causing it. So the magnetic field is not a disembodied line of force. All it is an abstraction that tells us one thing. It tells us the direction that the northern end of a magnet will be pushed at a given location. And of course, it indicates the opposite of the direction that a southern end of a magnet will be pushed at that location. You can see this image where the magnetic field is indicated by the direction all these compasses are pointing. I'm not trying to say that only an abstraction exists here. There is something physical going on here. There's a physical reason the magnets, all these little compasses, are getting pushed like that. My point is that we don't actually know the physical reason, and the magnetic field doesn't capture it. All it captures is the magnitude and the direction that the magnets get pushed. That's all it does. However, we do know one thing about the fundamental nature of magnetic fields, and that is that they are a property of the ether. The ether is a medium which is everywhere, even in a vacuum. One way we can tell that the ether is real is that if we suck all the air out of a chamber, magnets will still attract and repel one another. Now, combine that with the fact that we have experimental evidence that magnetic fields travel at the speed of light. So magnets don't simply act on each other over a distance.
Hold on. Now I gotta cover two things. One, back to that jar where he shows two magnets in it. And he says the ether must exist because we've sucked all the air out of this jar. Go back about 5 seconds or so. You can see the
Fields
one with
travel combined
AI.
with a
His
change.
little AI picture there. There it is. AI guy.
Shout
taking
out to
notes.
the AI picture, dude. That's my favorite.
Let's hear it. That AI haircut is rocking, man. I love that shit. Okay, so what he asserted there, which I couldn't believe he actually said it, is that we're proving ether exists because magnets still attract and repel each other in a vacuum. Okay, so what he's not really coming clean on is that, well, no, that does not necessarily prove ether, because what about the fact that there is still free space inside that vacuum out jar? That free space is actual, measurable thing, even though there's nothing in it in terms of matter. There is clearly energy exchange going on in the vacuum here. So that does not necessarily prove that there is ether present in the systems of transmission of one magnetic force to the other in terms of attraction or repulsion. That's one. The other one was way back when he was, if you want to take it back that far, remember we're at 513 here, so you can come back to that. But if you go all the way back to when he shows the magnet and the force and the arrow, you know what I mean? Right before he does the gang sign, keep going farther back. That's it, right there. Okay, so I got a problem with his nomenclature here, or his diagrammatic inability. Okay, symbolically, what he's got is a north and a south pole there in free space, in proximity to an object which carries a particular charge, with the positive sign there. And then he puts that little blue arrow going up out of the North Pole and puts a B on it. Well, where I come from, that B is electromagnetically generated. And for my world, in terms of the prototyping and science that I've done, the experimentation that I've physically done, the measurements that I've taken, the things that I've seen on the scope, etc., that's not the right letter. It shouldn't be a B. It should be an M. Secondly, if it's going to be a B, then he needs to draw the correct symbol below, not just the dipole, but the thing that creates it. In this case, axially, which in my estimation, my guess, would be something in the shape of a coil with current running through it, because there is an electrical component to the production of a B field in terms of current through a conductor, axially situated. This is the right-hand rule, which is the formulation of this gang sign rule that he was showing you involving three fingers. I hope that makes sense. That there are two different animals in terms of the mechanism here in free space, whether there's vacuum or not. And I will point out again, he's saying, well, like he asked before, what are we going to be able to do to advance science, to answer some of these questions, to get some of these experiments done? The answer is sweet Fakal. You can't do anything about it because we're stuck here on the surface of Earth. We are always in the ambient electrostatic field that is present everywhere between the surface of the Earth and the sky. And it is inverted in terms of the mathematics here with respect to R and the charge on that little white dot. That when we talked about the cross product and that R is relevant in terms of foot-pound in producing torque, the same thing is relevant in terms of calculating the field strength of that charged object. And it is a function of R. The closer to it you are, the higher the potential, the stronger the force, the bigger the F you will experience in proximity to the magnet producing this M or B field. Hopefully that makes sense to you guys. But as far as I'm going right now, this guy has yet to get to first base. All right, so back to 513, and let's see where he's going.
Dude, well said, Stone.
Product, which you can learn.
Oh, real quick, can you clarify? I missed why it should be an M instead of a B.
Yeah, because of the symbology that he's using. that he's drawn a dipole. He's drawn a physical magnet down below, the N and the S on it, that it is a block, and it has been magnetized through its length. And the north polarity force, those lines of force that he showed represented by the changes in orientation of the compass, which are actually showing you the orientation of the flux, not the field.
Ah, gotcha.
The field lines are perpendicular to the orientation of all those compass headings.
Right.
He's showing you the flux of the B field exerted on this charged, quote, particle, right? So he should have symbolically agreed with the B and drawn a coil around this, quote, magnet, dipole, however you want to label it. The thing that is generating the actual B field axially through its center. That's the difference geometrically.
Thank you.
Learn more
You bet.
about
513 was a magic number.
Nice. Here we go. Shout out to the AI production. I'm a fan.
of a chamber, magnets will still attract and repel one another. Now, combine that with the fact that we have experimental evidence that magnetic fields travel at the speed of light. So magnets don't simply act on each other over a distance. There has to be some kind of stuff that travels at the speed of light that conveys the magnetic force from one magnet to another. It could be stuff, or it could be some sort of change in an existing stuff. Whatever it is, this stuff has historically been called the ether. Now, physicists in the modern day almost universally reject the ether, and they are all wrong, and demonstrably so. Magnetic fields are properties that are telling us what kind of action will happen to a magnet at each location. Actions are always actions of some entity. There can't be nothing there acting. Nothing isn't a thing that can act. So there must be something, some entity at each location, some ether, which causes the magnetic forces at each of these locations. And incidentally, the ether is also responsible for many other fields and forces as well. This is just one of them. If you want to learn more about the ether, check out the second link in the description. In that video, I explain the importance of the ether, and I refute all of the arguments which are taken to disprove it, including the commonly referenced Michelson-Morley experiment. Once again, all the magnetic field is telling us is that the north end of a magnet will be pushed in a certain direction at a certain location. We don't know exactly what the ether is doing to cause this. But whatever it's doing, when it is in that state of being able to push a magnet in that direction, it's also able to push a moving charge in a different direction. Okay, to state that same point again, when the magnetic field points in one direction, the ether is doing something to cause it to push moving charges in a different direction. So now the angry physics student is going to ask me, well then what's the ether doing then? Well, Maxwell, the great integrator of electromagnetism, actually had a model of the ether that explained all of this. Maxwell modeled the ether as a set of tightly packed cells. In this model, magnets cause these cells to spin. When these cells spin, they fatten. They stretch out along this axis for the same reason you feel pulled to the outside of a spinning merry-go-round. So this fattens them along this axis and shortens them along their axis of rotation. Now, the northern end of a magnet causes these cells to spin in one direction, while the south end causes them to spin in the opposite direction. Now, if a north and south end of a magnet are next to one another, they spin the ether cells in the same direction. And this makes the ether cells spin really fast between the magnets, which causes them to flatten out and take up less space between the magnets. In contrast, above and below the magnets, the ether isn't spinning as fast. These cells are taller than the ether between the two magnets. This causes more pressure above and below the magnets, which pushes them together, so opposite poles attract. Now, let's consider Maxwell's account for why two northern ends will repel each other. The magnet up on top would cause cells to spin in a certain way, whereas the magnet on the bottom will cause cells to spin in the opposite direction. The net result is that the cells between the two magnets don't spin that much. In contrast, the cells above and below each magnet are spinning faster than the cells in between because they're affected by just one pole each. They aren't having their spins canceled. So these cells are flattened out by greater motion on the outside. The net result is that the cells between the magnets generate more pressure.
Wouldn't it be instead that because there's an absence of any other field outside of the south in either direction, those would not be changing from spherical at all, because that's what would be happening in its rest state with no other influence, any other magnet in proximity? But in between the two norths, wouldn't those sphericals there get taller instead? They'd get skinny because they're spinning slower. And that is the thing that would force the repulsion, not actually the fact that the other ones on the outsides are getting fat and pulling them apart. Anyways, just see how he resolves that.
It's a really good point.
Than the cells below the magnets, and that pushes the magnets apart. So northern ends repel. So according to Maxwell's model,
apart, right?
when there's a magnetic field in a
Sorry, what was that?
See, what he actually suggested was that the cells on the south sides, on the outside of the whole thing, weren't pushing it apart. They were pulling it apart. And the question is, if it really is the case that they were pulling the two magnets apart in a physical sense, what's anchoring the outsides of those cells on each south end? You know what I mean? If you were going to have something and you're pulling it, for example, you with a rope connected to your car and you're standing on the ground, the reason the car comes to you is because the friction between your feet and the ground, not just the fact that you're pulling on the rope. Right?
Yeah.
So in this case, there's no feet on the ground at either south pole.
Right.
So they could not possibly be pushing them apart, nor pulling. It has to be what's going on between the two norths that's actually doing it. All right, let's go.
Makes sense. Perhaps a little centripetal divergence.
repel. So according to Maxwell's model, when there's a magnetic field in a region, it's because these cells in the ether are spinning. Getting back to the subject of the video, he also had an explanation of why this particular state of the ether also caused charges to get pushed in that wacky direction by magnetic fields. To set that up, let's first think about how this model accounted for how currents generate magnetic fields. If we have a wire carrying current to the right, then it's going to rotate the cells adjacent to it along with the direction of current. This means that the cells above the wire are going to be turning counterclockwise, and the cells below the wire are going to be turning clockwise. Now, let's understand how this model explains why moving charge is pushed in that wacky direction. This is Maxwell's explanation for the student's question. So let's look at that same picture again, but let's suppose this time that there's a northern end of a magnet underneath the wire. Okay, so in this picture, imagine that you're looking down on the current carrying wire and imagine that there's a northern end of a magnet underneath that wire. Okay, so behind the screen. This would produce a magnetic field coming out of the screen. All of the cells surrounding the wire, top and bottom, are already spinning counterclockwise because of the magnet behind the wire. If there's current in the wire itself, that is also going to change the rotation of the cells, in addition to the rotation that's already there because of the magnet behind the wire. When the current runs, the cells above the wire are going to have their existing rotation sped up by the current, since their current spins in the same direction. Now, in contrast, the cells below are having their original rotation slowed down by the current, since the current pushes it this way. That's going to make the cells below the wire skinnier and the cells above the wire wider. This creates a downward force on the wire, since the cells above apply more pressure than the cells below. And if you use your second right-hand rule, sticking your trigger finger along the direction of current and your middle finger out of the screen, then we find that you indeed see that the force is downward, which is in agreement with Maxwell's model. So Maxwell had an explanation for this, of why when the ether is in a state that pushes magnets one way, then that state causes it to push moving charges in a different way. Now, unfortunately, this model of the ether is probably not literally true. Maxwell himself was the first to say that he didn't think the ether was literally a bunch of mechanical objects rotating and pressing on one another. My only point in bringing this model up is to show an example of what it would look like to understand the physical cause of these magnetic forces. What it would look like to understand how a certain ether state would push magnets in one direction while moving charges in a different direction. But what is the ether actually doing? Maxwell's models successfully modeled all of the known laws of electricity and magnetism, so it's at least equivalent to whatever the ether is doing on some level, but we have not yet found how far this model can be taken, whether it's consistent with more advanced observations which have been made since Maxwell's time. So, unfortunately, this poor disturbed soul will just have to kill me, I guess, because I don't actually have an answer for him. We don't know exactly why the ether behaves this way. All we know is that when it is in a state of pushing magnets in a certain way, that state will cause it to push on a moving charge in a different way. However, I can point you to the way towards how to answer this question in the future. What we're going to have to do is use our understanding of fields, our understanding of the actions that the ether causes at different locations, to make inferences about the underlying nature of the ether. In other words, what the ether is doing to cause those actions, which are only represented by fields. We must do what many physicists won't, which is to look beyond the abstraction of fields and find their underlying causes. Understanding more about fields, how they relate to one another, and how those relationships could shed light on the underlying nature of the ether is one of the long-term goals of Inductica. So hit subscribe and join us on that journey. To support the project, go to patreon.com/Inductica. Members will enjoy access to my 34-hour lecture series, an inductive summary of physics, as well as access to my book, which presents a theory of the scientific method. You can also visit inductica.org/contact to inquire about one-on-one physics and math tutoring. So I hope you enjoyed this video, and I hope you'll join me as this inductive journey continues.
I'm still enjoying it, buddy. Okay, let's go back about a minute into that, towards the end of that video. Last time he shows
relate to one another.
Actually, no, let's go even farther back. Another minute or two to the beginning of where he started to show those cells, just before the polar shows up. Keep going back a little bit more, I guess.
How's that?
Or maybe it's just to the right of where you had it. Yeah, just before what you're seeing now, before that end shows up. And he shows one more diagram before that. Keep sliding to the left then, I guess. There. Just to the right of here so we can see the cells too. Search forward just a little bit. That's the electrical current, the voltage delivering current through a resistive conductor. Okay, great. Now, this is his annoyingly 2D representation of what Maxwell was trying to gift us with here. And what we need to see here is the fact that this is a really poor 2D representation of what he's trying to show you in terms of the interaction between free space through which this conduit is passing current. Okay? This looks like it's all been dropped on a table, and we're in the top view, and balls are spinning while they're sitting on the table. When in actuality, we should be viewing the sum of all of the dots that are around all of this axis of the conductor. And what you see is a resultant shape is a vortex. You see a donut. Can you guys see that? Where the dots would be coming out of the page radially around the conductor and into the page radially around the conductor, and that all of the arrows would be closest in their path incongruent movement with the current.
Let's see. Kind of like a.
See, none
like,
of them show it. This is
kinda
all
like-
2D.
Kind of like that.
No, nothing like this. Nothing like this. No, go back to the video. This is not it at all. Because what we're doing is we're using voltage to drive current through a resistive conduit from left to right on the page, right? The dots you see here, this is only one slice of all of the dots which are present around this conductor. Rotate the image axially with respect to the conductor, and you will see that there are dots in and out of the page. 3 dots thick, 4 dots long, all the way along the conductor, around the entire circumference of the conductor. That produces vortexual dynamic between the conductor and free space. Can you guys see that? That those dots are not just a flat set of 12 dots on each side. There's closer to 60 dots, or 12 times, however many times you want to slice the angle, the radiative around the conductor itself. Like if you took this entire thing and rotated it 90 degrees so that you're staring in parallel with the conductor, you would see 3 concentric rings of dots around the conductor, 4 deep as you go through the page, as you go along the conductor. It's actually a vortex.
Yeah, I can kind of see what you're saying. I think, Shane, are you there? He has a really good image of like a double donut vortex, and I think that's kind of what you're putting forward as like a 3-dimensional aspect, which would generate, the field gradient and all of that as like a 3-dimensional construct rather than like a 2D cross section.
It would produce something rather toroidal, wouldn't it?
Yeah. I was kind of looking at this would be like a straight on view of like a cross section of it. Well, this isn't even like the picture I was looking for, but it would be like
But even on that picture, I think they've misdiagrammed it or mislabeled what they're actually looking at in that picture. Those are not the lines of force. Those are the lines of flux, which cause force in those directions.
right.
The field lines of force are perpendicular to those lines, and they get closer together in terms of a metric as you get closer to the charge.
Dude,
And secondly, there's no such thing as a negative charge, but that's a whole other argument.
Yeah, I was just watching a video from Fractal Woman where she was talking about how when you put a ferrocell next to the magnet, that the iron filings aren't aligning with the field lines; they're aligning with the flux lines.
Precisely. The field lines are what actually cause them to move in the directions and concentrations that they are moving. Yeah.
Dude, that's awesome. Cool. Was there another section that you wanted to cover before we close out our boy?
I think we're pretty good with cutting this guy to pieces up to this point. It's been a slice, pun intended.
Yeah. Well, dude, like I didn't, dude. I forgot about most of the stuff in the video. So it was kind of like watching it for the first time, but still recommend him. He's a good lad out there. Check out his stuff. All right. And if anyone is looking to get some coffee, I think Liliana had a testimonial she wanted to share with everyone since she started drinking Brushtail coffee.
Hey, before that, I wanted to just make a quick comment, just a quick comment / question. It sounds to me like these modern physicists want to kidnap ether and kind of like replace dark matter and dark energy with it. Is that kind of what's going on? So they don't sound as lame?
I can only guess as to what their motivations really are, other than to just tell us how it ain't.
Yeah. Uh-huh.
I don't think I could put that any more eloquently than that.
Yeah.
And even when it comes to ether itself, I think there is just so much confusion, conflation, distortion, and mismanagement of the concepts when people start to talk about ether and the cause and effect. Like the same thing I was pointing out in this when he had his AI guy with the two magnets in a vacuum, you know, and of course blaming it all on ether. And the way that the entire Michelson-Morley strata of experimentation was set up and the premise that it was built on, I'm not really there with them. I'm not in agreement at all on the premise, nor the variable itself. And it is evidenced, like I referenced earlier, it is evidenced in the electrostatic field in which we exist. We all know that magnetic fields and electric fields can change the direction light travels. I mean, that's what we did with cathode ray tubes and the like and everything in between since then. And I don't think enough attention is being given to people like Eric Dollard, who coined the term counter space, and looking at the simple reactions, even in something like an inductive, the magnetoelectric effect, or the, you know, anything like that, that we're just starting with the wrong mindset. And because we are, there is no hope that we're ever going to arrive at the correct answer, going in the directions that mainstream has been going. And even some of the alternative have been going. I'm just not there. And that is why I got a month or something ago, I spent some time talking about how I perceive a vast difference between what people call ether and the etheric influence on light here down on the surface of Earth, and counter space, to do with electromagnetic induction and that whole slate of electromechanics. I just don't see it the same way, I think, is what I'm trying to say there. And right now, the premises that are being used as a foundation in experimentation, I think, are fundamentally incorrect.
Thank you. Yeah, I think I'll just save the longer testimonial for another time. But I just want to tell you guys that brushtail coffee is really delicious. I normally used to buy really expensive, good quality, organic, fair trade, very good coffee, single source from health food stores, because I only shop for like dry goods at health food stores because I buy all my produce at farmers markets. But I have to say that Toby's coffee, brushtail coffee, is way better, and that he does take care to make sure it's fair trade. And even if the small farmers are unable to be certified organic, they are in practice, they are using organic methods. So he's very meticulous about what kind of coffee he gets, and I have not been disappointed at all. I've been trying various source of the coffee. So yeah, but I do have a great testimonial for next. We'll save it for next time. It's a little bit longer than I want to use up time for today. So, and also please support our teachers, Alan and Shane and Stone. They give us incredible content. And I think that, the monthly subscriptions are the best idea. And I think, honestly, like if you really want to have more logic in your life, because I think logic will always improve your quality of life. It just does. I think that once you get into the habit of listening to the voices of logic, you will be able to just apply it in different parts of your life because your brain starts working differently. So I really recommend, taking the time and spending time watching the great content that they put out. And if you subscribe, you will have some skin in the game and you will take it a bit more seriously. And really, the person that has to gain the most from it is us, the subscriber. So the teachers are doing this just for the love of knowledge, and they put out all this incredible content for free. So let us show appreciation, because karmically, that's really good. If you consume their content, give something back, because it just is it's the cycle of life. You keep that cycle going. So lots of love to the teachers and to the audience. And thank you again for everything.
And that's why she's our ambassador.
Well said, Lily. And special shout out to Stone, man. Your expertise is really appreciated in breaking down these subjects and correcting some of the things that were, misrepresented or, maybe not necessarily articulated in the best way. Your input is so valuable, man. We really appreciate what you do around here, and you dedicate your time for nothing, dude. And it's crazy, man. Just you're a bad motherfucker, dude.
Alan,
So glad I could make it by.
Alan, I want to figure out how to post more of Stone G's videos on Twitter. I'm so sorry that I haven't been able to figure that one out. But, it's easy for me to just retweet the stuff that you and Shane put out. I want to be able to do the same thing with Stone G's videos. Thank you. If that's okay with Stone G. Thank you.
Yeah, I can walk you through how to do that. But yeah, I'm going to wrap up now. So thanks everyone for tuning in. Tomorrow will be Flat Earth Fridays, episode 117. So stay tuned for that. And then, of course, Tuesday will be in a new breakdown of Michelson Morley, just focusing on that and then building a series on the history of interferometry.